Here's a problem from the 2025 AMC 10. It's problem number 11. Let's read it together. The sequence 1, x, y, z is arithmetic. The sequence 1, p, q, z is geometric. Both sequences are strictly increasing and contain only integers, and z is as small as possible. And it asks for the value of all 5 of those numbers together. Let's take a look at how we might approach this. I'm going to start with the arithmetic sequence 1, x, y, z. Question for you, what is the difference between terms? I'm going to start at the beginning and we can infer that the difference is x minus 1. So I could rewrite the terms of this sequence as 1, x, 2x minus 1, and 3x minus 2. This will be important because we're going to establish values for the terms that are in common. In particular, there's a z at the end of the arithmetic sequence and a z at the end of the geometric sequence. So now let's take a look at the geometric sequence. This is my arithmetic. This is my geometric 1, p, q, z. What is my ratio? Of course, if I'm going from 1 to p, my ratio is p. So I could rewrite this as 1 p squared, p to the third. And now we have established an equivalence. That p to the third equals 3x minus 2. Now the value of z is as small as possible, so it's actually going to help us if we start with values of p. And let's see if we can get something for p where the right side will result in an integer value for x. So let's try, we're going to start with p equals 2 because it's strictly increasing, and a geometric sequence where r equals 1 will not increase. So let's just try p equals 2. This gives us 8 equals 3x minus 2. I'm going to leave that as trivial to show that the value for x is not an integer because I get, I get 10/3 for x, right? So let's try p equals 3. 3 to the third is 27 equals 3x minus 2. That's going to give us 29/3 as a value for x. That's not an integer. I'll just put this up here, 10/3 equals x. And when p equals 4, I get 64 equals 3x minus 2. Oh, well, look at that. 66 equals 3x, and now x equals 22. All right, I've established the value for x that makes things work, and for p, actually. So now if I rewrite my geometric sequence, I have 1, 22. That means the difference is 21, 43, and 64. And for the geometric series, I have 1, 4, 16, and 64. So of course this is x, y, and z. This is p, q, and r, p, q, and z. This is p, q, and z. And the problem asks for x plus y plus z, x plus y plus z plus p plus q. So 65 and 64, 129, 133, 149. Which is answer choice E. Okay, hope you like that. An interesting connection between arithmetic and geometric sequences. Also some interesting problem-solving strategy there. Any questions, or would you do this differently? Let me know in the comments, and I hope to hear from you about any other problems you'd like to see discussed. Drop a note in the comments as well. Thanks for watching.